All right, everyone, this is our last video. I hope you guys are having a great week of break, and I'm looking forward to seeing you guys on the Friday of the week we come back from break. So you're going to need your last two sheets that you haven't filled in. One should say 4.6 square roots and the Pythagorean theorem, and then the other one is the lesson out of the book. So this was a note packet that we were going to just take some notes on in class. So you need a calculator. I have both calculators that we typically use in class, so we can find what those keys are that we're going to be using today with square roots and cube roots. All right, so take a minute, and you can use your calculator if you need to find all these numbers that are called perfect squares, like 1 times 1, 2 times 2, 3 times 3. So go ahead and finish that up, finish that column up. You can turn off the video if you need to. And then come back and check with my column. Okay, so these are just some perfect square, what are called perfect squares, numbers that are multiplied together by itself to get this nice product. So we're used to going from this direction to this direction, right? From here over to here. And now we're going to go in the reverse. Now we're going to start on this right-hand column and work our way over to figure out what number we squared to get 100, or what number did we square to get 81. So the reverse operation of squaring is what is called the square root. So for example, this is read the square root of 25. And to find it, you have to ask yourself, okay, what number, when I multiply by itself, gives me 25? So it's 5 right up here. We multiplied 5 by itself to get 25. So when it says, what's the square root of 81? We said, okay, what number, when I multiply by itself, gives me 81? And 9 squared gives me 81. All right, so flip right here. So it says the square root of A equals B if B squared equals A. I know that's kind of confusing when you see it that way, but let's look at it. So the square root of 25 is 5 because 5 squared equals 25. So when I look at this, I say, what number did I multiply by itself to give me 25? And that's 5, because 5 times 5 is 25. Now there's actually two different answers for these, because we could also say negative 5 times negative 5 equals 25, right? So there's oftentimes two different answers to these problems, and we'll look at that in a minute. We'll look at it why in a minute, but let's just look at what are called the positive principal roots. So the square root of 4. Now, if you're not sure what it is off the top of your head, let's find our square root symbol. It's right above the squared key. Mine's in green, so I have to hit the green key first. And then I would put 4 in. So the square root of 4 is 2, because we ask ourselves, what number, when I multiply by itself, gives me 4? And that's why the answer is 2. Okay. If you have this calculator, you'll see the square root symbol is the same place. It's right above that x squared key. Okay, so let's do the square root of 36. It's 6, because when I say what number, when I multiply by itself, gives me 36, it's 6. Okay, so let's figure out what this is. Negative root 9 is -3. All right, so how does this work? Well, the negative's outside that grouping symbol, so first we say, all right, what number, when I multiply by itself, gives me 9, so that's 3 times 3 is 9. So root 9 is 3, and then that negative kind of goes along for the ride. So it's like root 9 is 3, and then this negative kind of pops right out in front of it. Now on this one, I'd really like you to try putting that into your calculator. You should get some sort of error message. So this does not exist. Now some of you might say, well, why not -9? But -9 times -9 is +81. There's not a number when we square it that will give me a negative number. So it does not exist because when we multiply a number by itself, we always get a positive number. So we cannot take the square root of a negative number. And then I just wanted you to try those two on your calculator. So we'll go square root, let's clear that out of there, and we're going to just put a fraction in of 1/4. So we can take the square root of fractions and decimals. Oops, forgot my negative. So you see that the negative is outside the root symbol, and that's why we're allowed to take the square root. We're taking the square root of a positive number, and then we're making that number negative. All right, so one of the big applications that we're going to be looking at, and this is on the test and on the final, is what's called the Pythagorean's theorem. Now, Pythagorean's theorem only deals with what are called right triangles. And a right triangle is a triangle that has a corner as one of its sides. You might have learned that corner is a 90-degree angle. And what Pythagorean's theorem says, that if we square each leg, the sum of those squares is equal to the square of the side that's opposite the right triangle. Now let's talk about what the legs are. So A and B are the legs of, they're called the legs of the right triangle, and they're the sides that make the 90-degree angle. The side opposite the right angle is what's called the hypotenuse. And it's the longest side of the triangle. It's the hippo, the longest side. So A and B are the legs that make the right angle, and the side opposite is going to be what's called the hypotenuse, and that's the longest side of the triangle. And if you sum the squares of the lengths of the two legs, it's going to equal the square of the hypotenuse, which is typically called C. So let's play with a couple of them, and then we'll see what we can make of the actual book work. Now, we already talked about this. A right triangle is a triangle that contains a right or 90-degree angle. The legs are the two sides that form the right angle, and the hypotenuse is the side across from the right angle. And the hypotenuse will always be the longest side of the triangle. Now, Pythagorean's theorem only works with what are called right triangles, those triangles that have a right angle. So let's start playing with some of these. You don't have to memorize this formula. It's given to you, but we have to know how to work it. So it doesn't matter what you call A and B, but C does matter, right? Because it's the side opposite the right angle. So this says 3 squared plus 4 squared equals C squared. Now we can do this on our calculator. This is a very special kind of triangle. It's called the 3, 4, 5 triangle. Okay, now at this point, if you weren't sure where to go, it's all about undoing operations. We've never been given a chance to undo a squared. So if I'm looking at this equation and I want to undo that square, a square root and a square undo each other so that the letter falls out. So length C is 5 inches. Let's try this one. All right. So it looks like we're missing one of the sides. Now you can decide which one you want to call A and which one you want to call B. It doesn't really matter. I'm going to go A, B, and C. So A squared plus B squared equals C squared. A is 5 squared. B we don't know. And we know the hypotenuse is 13. So 25 plus B squared equals 13 squared is 169. So to undo a positive 25, we're going to subtract. You're trying to get the B by itself. Okay, I have a B squared, and I want to undo that squared symbol. So to undo a square, I take the square root, and then the letter falls out. So the square root of 144 is 12. So the missing side will be 12 feet. So let's look at this one. So it looks like I have the A and the B. It doesn't matter. Do you see how I can flip them around? It doesn't matter which one you call A and which one you call B. But C does matter because it's got to be the hypotenuse. So A squared plus B squared equals C squared. So 36 squared plus 15 squared equals C squared. Let's pull out our calculator. So 36 squared plus 15 squared, that's 1,521 equals C squared. So to undo that squared term to get C by itself, we take the square root of both sides. The square and the square root cancel each other out. And we're given the square root of 1521, which is 39 feet. And you'll notice that the hypotenuse is always bigger than either of the two legs. Did you notice that? So 13 is bigger than either 12 or 5. 5 is bigger than 3 or 4. Now, sometimes they won't come out to these nice numbers, and then we'll just round it to the nearest hundredth or nearest tenth. All right, so it looks like we have A and B, but we're missing C. So why don't you try pausing the video and see if you can fill in A and B And then use your root key to solve for C. Right, I'm going to go ahead and try it. So I'm given the two legs, and I'm looking for the hypotenuse. So I have 22 squared plus 48 squared. That's 2,788 equals C squared. We're going to round our answers to one decimal, so we might need to hit the change key. So the squared and the square root cancel each other out. And let's go ahead and take the square root of 2788. So it looks like it's 52.8 meters. And then let's try one where we're trying to find a missing side. It doesn't matter which one you label A and which one you label B. So A squared plus B squared equals C squared. So in this case, we're looking for A, B is 10, and C is 12. So 10 times 10 is 100, and 12 times 12 is 144. We got it now. Before we can't use the square root key yet, we have to get the letter by itself before we're even allowed to look at that squared key. So A squared equals 44. You see the squared terms all by itself, so now I can go ahead and take the square root of both sides. And then the square and the square root cancel out, and the letter comes out of the root symbol. Now, if you get something like this, you have to change it, because they'll want you to round it to the nearest tenth of a decimal, the nearest one decimal point. So hit change, and there's your 6.6. So it looks like A is 6.6 centimeters. Just a couple more on the back, and then we'll actually look at the book. So this says, a park in the shape of a square measures 300 feet on each side. And what they want to do is they want to make a sidewalk that's going to go right along the diagonal. So this is my unknown. Do you see when you make a diagonal, you make a right triangle? And that diagonal is going to be the hypotenuse. So we'll have A squared plus B squared equals C squared. Each of the legs, they're the ones that make up the right angle, is 300 feet. So pop those in for A and B. Let's see what that left-hand side looks like. So 300 squared plus 300 squares is 180,000. And then to solve for C, to undo that square, we're going to take the square root. So it looks like the sidewalk is going to be 424.3 feet. But if you read the problem, it says round to the nearest whole foot. So they're going to ask us to round to 424 feet. Oh, I wrote the 2 though. 424 feet. Last problem, and then we'll look at the book. It says, find the height of the antenna. So do you see the triangle? We have this tower here, this antenna. And then it looks like it may be a cable that's running up to the top. So this is 60 feet. And then it looks like the cable is about 168 feet. Here's the right angle, right? And so we're looking for the height. And again, you can label any of these whatever letters you want. So if this could be A, this could be B, and that could be C. It doesn't matter how you label the A and the B. So A squared plus B squared is C squared. We don't know A, but we do know one of the legs is 60, and we know the hypotenuse, which is across from that right angle, is 168 feet. So let's pull out our calculator, see what some of these numbers look like. So you'll be doing this on your calculator too. So then you know you're comfy cozy with using your root key. So to get A squared by itself, we'll subtract 3,600 from both sides. And then we have to undo the squared key. So to undo the square, we take the square root. So the square root of 24624 is 156.9, 0.9 feet, one decimal place. So that's how tall the tower is. All right. So that's kind of just the backstory. And the lesson won't seem so terrible now because we've done so much of it. Now, the one thing I want to point out is this paragraph down here. So they said when we're solving for this, for example, x squared equals 41, to undo the square, we take the square root. Now, the calculator will give us one of the answers. So when I put this into my calculator, change it. It gives me the 6.403. That's what they have right here. But there's also another number when I square it that will give me 41. And that's the negative. That number that the calculator gives us. Our calculator gives us what's called the positive principal root. But there's really two answers when we solve these, right? So the calculator, when I take the square root of both sides, the calculator is going to give me 5. But really, there's another number that when I square it will give me 25, and that's negative 5. So this is kind of the new stuff, is they're letting us know that, hey, when you do these on your calculator, there's really two answers. One will be positive and one will be negative. The calculator is only going to give you the positive value. All right, so let's play with solving some of these equations. So let's look at what they did on this. They said we need to isolate this x squared term. So the first thing we're going to do is add 3 to both sides of the equation. So that's where we get the x squared over 5 equals 7. And then we're going to undo the dividing by 5. So it says multiply both sides by 5 to undo the division. And then it says, okay, we have to undo the square. So we're going to take the square root of both sides. But remember, there's 2 different answers where one is positive and one is negative. So sometimes you'll see it written like this, or they'll just write like this, where one is positive and one is negative. All right, so you could try some. Take a minute, see how you do with those 3. I'd really just like pause the video and just see how far you can get with it. All right, so hopefully when you solve this, you took the square root of both sides. The calculator will give you 9, but you got to remember there's a negative root that it won't give you. It just gives you the positive principal root. So we can't think of taking the square root until that squared term's by itself. So we'll divide both sides by 3. And then we'll take the square root of both sides. You can't take the square root until that letter is all by itself. So the calculator will give you the positive 2, and then you have to know to put the negative 2 as well. All right, let's try one more. So we're going to get this by itself. To undo addition, we subtract. And to undo multiplication, we divide. We can't think about the square root symbol until that is all by itself. So 200 divided by 5 is 40. And now we can take the square root of both sides. So the x falls out. And then let's hit change so we can round it. So 6 point, does it say what to round it to? It doesn't. We'll just go 6.325 and then negative 6.325. All right, let's try one of these things. So we know the area formula is pi r squared. So now it's a little bit tricky because they're going to tell us that the area is 300 square meters, and they want us to solve for the radius. Well, that's no problem. We know how to get this r squared by itself. We're going to divide by pi. So 300 pi equals r squared. And then to undo the square, we're going to take the square root of both sides. Now we can't have a negative radius, so I'm only going to use the positive value that the calculator gives us. So it looks like the radius is about 9.77 and it's in meters. You don't want the negative part because you can't have a negative radius. All right, let's see what else is on here. Oh, another breaking distance. Look at that, we're just about done. Now we know this formula. We've already dealt with breaking distance. And here, they gave us the simplified version of the formula where they told us what G is and F is, and they put those into the denominator and gave us the simplified version. So it says there was a car crash, but the police went out and measured the skid marks. So it looks like it took the car 120 feet to come to a complete stop. And they said, okay, how fast is the car going in miles per hour? Well, we know how to undo division. To undo division, we're going to multiply. And then we now know how to undo a square. So to figure out what the velocity is, and we have to be careful because when we take the square root of this, we only want the positive principal root. So we can't go at a negative speed. But we have to remember that this is going to give us an answer in feet per second. So let's see how fast the car was going in miles per hour. Right? So you remember when we did this, this formula uses feet per second, and then we had to convert it to miles per hour. So this is how fast the car is going in feet per second, right? V is the velocity of the car in feet per second. So now, if they want it in miles per hour, let's go down here and just do a little conversion. 595 feet per second, and then we'll do our little bunny trails. So we know, and you don't have to memorize this, in 5,280 feet, there's 1 mile. So the feet will cancel. And there's 3,600 seconds in 1 hour, right? We want the seconds to cancel, so we had to put them upstairs. So now we can get our answer in miles per hour. So we have 74.595. You can use fractions if we went over 1 times, and then we'll have another fraction where we have 1 on the top and 5280, and then times another fraction where we have 3,600 on the top and 1 on the bottom. So it looks like they were going 50.86 miles per 1 hour. How did we do? So let's try this one, and then we're just about done. It says a car took 240 feet to brake. Right, so let's try this one. I'm assuming if it took that long to brake, then they're going much faster. They're going to be going much faster than this. So if it's 240 feet, here's our formula. So we'll just repeat the process. We're going to undo division by multiplying because we want to get velocity by itself. And then we'll undo the squared by taking the square root. Now you can't go a negative velocity, So we only want the positive principal root. So they were going 105.493. Now remember, this formula is in feet per second. So if we want to convert that to miles per hour, you know how to do this now. We've done it a bunch of times. So you need the two conversion factors. So we'll repeat. If we want to get rid of feet, we put feet on the bottom and miles on the top. And in 1 mile, there's 5280 feet. And then to get rid of seconds, since seconds is on the bottom, we'll put seconds on the top. And we want this to be in hours. Miles per hour, because we're going to compare it to that. We know it's going to be faster than that. Let's see. Okay, there's, oops. Do that again. We'll put these three fractions in. So 71.927 miles per hour. So we knew it was going to be faster, right? Because the skid marks were, double. So we knew it was going to be faster. Let's see, so let's circle that. Right, I'm going to just make sure I plug that in right. So 105, oops. What didn't fact check? Oh, I did it again. I just want to make sure that that's right. We knew it was going to be faster, but I just want to make sure I plug that in right. Yep, 71.927 miles per hour. Okay, and then the last little bit is another Pythagorean's question. And I bet you could do this. Maybe you should just pause the video and read it and see how you do on it if you're not too tired. Because we've done a bunch of these now. So for this, it says the legs of the triangle, one is 6 feet and the other is 8 feet. And they want you to find the length of the hypotenuse. So 6 squared plus 8 squared equals c squared. Oh, so we know what this is. What number, when I square it, gives me 100. Now again, because we're talking about length, we only want the positive principal root. You can't have a length of negative 10 feet. Right? Now this one says, suppose someone wants to build a wheelchair ramp up to their front door. All right. So let's say this is the door. Okay. And they want to build a ramp up to their front door. The side of the ramp against the house is 2 feet above the ground. Okay. So this is what the ramp looks like, and it's 2 feet above the ground. It's going to look something like that. So that someone could use their wheelchair, right, to get into the front door. Right here's the front door. Okay. Pretend that's a door. So this is 2 feet above the ground, and the ramp's 8 feet long. And they want to know how far out from the house will the end of the ramp be? I'll just call that A, because there's your right angle. Okay, A squared plus B squared equals C squared. So A squared plus 2 squared equals 8 squared. So A squared plus 4 equals 64. So we can't think square roots until that A is all by itself. And then to undo the square, we take the square root. So the square root of 60, change it, is 7.74, how far do they want us to round it? 2 decimal places. So 7.745, so that would be 7.75 if it's 2 decimal places, feet. So it looks like it's going to be 7.75 feet away from the front door. And remember, we knew it was going to be less than 8 feet because 8 was the hypotenuse. So that makes sense that it's 7.75 feet. Then the last little bit is how to undo a cube root or a fourth root. So on your or a cube or a fourth, you have it's 2 places we can look. For this calculator, we're going to use that key there that has the little X in it. So if I want to know what number, when I cube it, gives me 27, to get rid of a cube, we're going to take what's called the cube root. And the cube root and the cube cancel each other out. So you have to put the number in first, like the root, like cube root or fourth root, and then we'll hit that key right there. And we'll put in 27. So the cube root of 3 is 27. Now we can't consider roots until we get that variable all by itself. Okay, so 56 divided by 4 is 14. So what number, when I multiply it by itself 3 times, gives me 14? Well, to undo a cube, we take a cube root. The cube and the cube root cancel out. And then to take the cube root, you put the 3 in first. To see how it becomes the root? And then we'll put in the 14. Now, if you have the other calculator, let me show you where you can find it. You ready? So underneath, well, there's a couple places. Do you see you have a math key? And then right there is your cube root. It's option number 4. So the cube root of 27 is 3. And then if you hit math, and option number 4, we can take the cube root of 14. And we'll try this one. Now if you have an even root, this is where we're going to have our 2 answers. If you have an odd root, you only have 1 answer, and we'll talk about that more on Friday when we meet. But I just want to show you how to take the 4th root on your calculator. So to take the 4th root, if you have a calculator like this, that's where you're going to need to put the 4 first and then use that key like I was showing you on the other calculator. So when we hit number 5, do you see it has the 4th root? So I'll do that again. You have to hit the 4 first, hit math, and then do you see option number 5 has the X where the root would be? And then you can plug in your 50. So 2.659. On this calculator, you have to put in your 4 first, and then you want that number above the caret key. You want that key right above the caret key. Is it 50? There you go. So we'll practice with these 2 keys when we meet on Friday. And we will also do a question like this when we meet on Friday, because this is something on your test and on your final. So an artist got this in the mail, and they wanted to make a sphere out of it or a ball out of it. But you see, the volume of the clay is the same for each of these shapes. So basically, they're just going to roll in their hand this block to make it look like a basketball. So we know this volume equals length times width times the thickness. So 6 times 4 times 2. So this looks like it's going to be 48 cubic inches. So they have 48 cubic inches of clay that they're going to roll in a ball. And they want to know, how big is the radius of the ball going to be? Well, the volume of a ball or a sphere is this. So if we know that the volume is 48, we can solve for r because we know how to undo a cube. So let's go ahead and divide by 4 over 3 times pi to get r cubed by itself. Now, this looks kind of ugly, but it's not so bad because it's just a fraction. We have 48 in the top, and then we have another fraction in the bottom, 4/3 pi. I'm going to do that again so you can see it. So we have a fraction. We have 48 in the numerator of the fraction, and then in the denominator we have another fraction, 4/3. I'm just using my arrows to kind of manipulate through the denominator. Okay, so this is what r cubed looks like. And to undo a cube, we take the cube root, because the cube and the cube root cancel each other out. So let's go ahead. We have to hit the 3 first, and then that symbol above the caret key. And let's put this number in, 11.4591559. There you go. So it looks like the radius, did they ask us what to round it to? Nope. Looks like the radius is about 2.2, I'll just say 545 inches. So when we come back, I'm going to have a worksheet made up that will give us some practice where we can ask questions and go over Lumen and make sure that we're all in cahoots with these rather long videos. All right, but I hope you guys are having a good break. I hope you're getting some time with your friends and family and kids. And I look forward to seeing you guys on the Friday after break week. All right, take care, everyone. Hope you're having a good day and a good week.